Good morning. Today I know that you are supposed to practice on your own, but let me just complete the lesson for a short time, and then I will give you most of the time to practice on your own. Okay. Uh, so one problem that we solved last time. Let me just repeat it again. There was no time that I can solve it in a different way. So do you remember? I think if that is the question that I have written here. So one question was that we know that a is an integer, and if we divide this integer by 5 and 7, so if I divide a by 7 by 5, the remainder becomes 4. If I divide this number by 7, the remainder becomes 2. Yes? So that's the remainder here. So I have a fixed integer. Once I divide it by 5, I get 4 as the remainder. Once I divide it by 7, I get 2 as the remainder. And the question is that if you take the same number, but this time divided by the product 35, what will be the remainder? Yes? So that was the question. So I wrote it on the board. We solved it in one method. If you don't mind, let me just review what we did before. Okay, so when you say that a divided by 5 gives me this remainder, what does it mean in mathematical language? It means that one can find a unique integer q so that a is equal to 5 times that q plus the remainder, which is given to be 4. Yes? And then when you say that when I divide a by 7, the remainder is 2, one can translate this into mathematical language, saying that there exists probably another q prime. You have to respect that you choose another letter, such that if you divide a by 7, you get remainder 2, meaning that a is 7 times that q prime plus 2. Now the question is that how can I find the remainder of a by 35? So if you have that question, it means that in a scratch paper, your goal is to do what? Your goal is to be able to find a as a multiple of 35 plus r. Yes? So your goal is to be able to write a in this form somehow. But the crucial point is that this r should be a number greater than or equal to 0 and then less than 35. So this is the goal. In a scratch paper, you write it in front of your eyes so that you know what to do. So from these two equalities, somehow I should be able to deduce an equality of that form. Yes? So if you remember the method we started solving this last time, I don't remember which one I multiplied by 5 or 7. One of them should be negative, the other one would be positive. So I don't remember exactly what I did. So let me just do it naturally here. So I multiply this by 7. So this becomes 7a. What is my goal by multiplying by 7? I want to make 35 appears, yes? So this becomes 7a is equal to 35 q's. And then I multiply 7 here, it becomes 28. This time, I multiply everything by minus 5 here. It becomes minus 5a. And then this becomes minus 35q prime. And then that becomes minus 10. Okay? And then I started adding them. This, unfortunately, that was problematic a little bit, because if I add them, 7a minus 5a becomes 2a. On the right hand side, I will have this added to this. So if you don't mind, I can factor a 35 out. And then what is left here is q. What is left there is minus q prime. And then, of course, 28 minus 10 is 18. So everything that I have done is completely correct, okay, but it is not useful that much right now, because of course, here I can call it capital Q. Then I will have 35 times capital Q plus 18. Capital Q is an integer because Q and Q prime are. 18 also satisfies this, but the problem is that I have a 2 here. Yeah, so that I should. So this means that by subtracting these two, you got this. This means that if you divide 2a by 35, the remainder is 18. But the question is not asking what is the remainder of 2a by 35. The question is asking what is the remainder of a by 35. Okay, so this motivates probably to divide everything by 2. This is the method actually we used there. So if I divide by 2, then 35, instead of this, I would write q minus q prime divided by 2. Of course, I could write 17.5, keep this one the same, but I don't want to change to 35, so it motivates me to divide this part by 2, and then I will have plus 9. Yes? Okay. And then from here, if you jump to the conclusion that, okay, I can call this capital Q and 9 satisfies that condition, so 9 is actually the remainder, coincidentally it is true with the wrong argument. Yes, so if you just immediately tell me that this is the case, even though the answer, as we will see, is 9, but this is not correct. Why? Because in principle, you cannot call this q, because what matters is that q should be an integer. And there is no guarantee that q minus q prime divided by 2 is an integer. Yes, q is an integer, q prime is an integer, but if I subtract, it might be an odd number. And if it happens to be an odd number when I divide it by 2, it is no longer an integer. Yes? So either I should find another method, or I should understand that or I should be able to prove that q minus q prime is indeed even. If I can show q minus q prime is indeed even, then actually I am done. Yes? And then we followed this to understand that this is really true. It is even. Why? Because I came back and said that, okay, this combination is A, this combination is also A, so these two should be the same because they are equaling to the same number. So this means that, for example, 5q plus 4 is equal to 7q prime plus actually 2. Yes? And then what did I do? Do you remember? So I moved this one to the left. Yeah, I don't know which one I moved, but it doesn't matter that much. So let me just move this to the left and move this to the other side, which becomes minus 2. But because I want to have the combination q minus q prime, so what I do, I will break it into two parts, minus 5q prime, minus 2q prime, and then equals to minus 2. So between these two, I factor a 5 out, q minus q prime, and then I move this to the other side. So this becomes 2q prime plus 2. Yes? Sorry, minus 2. And just one more step. 5 times q minus q prime is equal to, if I factor a 2 out, q prime minus 1. Okay? But one thing is clear. This number is definitely even. Why? Because q prime minus 1 is an integer. Whatever it is, odd or even, when I multiply it by 2, definitely it becomes even. Yes? And this one is equal to an even number. So this means that this combination should be even. So therefore, 5q minus q prime is even. Yes? Because it is equal to an even number. But when this is even, what can you conclude about this one? When you say it is even, it is a multiple of 2. But 5 itself doesn't contain any 2's in it, yes? So the 2 that is coming for evenness of this number is coming from this, that this should be even. Is that understandable? So 5 times a number is even. This means the number itself is even. Yeah, so this means that q minus q prime is even. And of course, if q minus q prime is even, in this case, I need q minus q prime. That's exactly the same combination, by the way. Yes, that's q minus q prime is even. So, and then it means that q minus q prime divided by 2 is an integer, which we call it capital Q. So if I go back and rewrite this equation again, so this becomes A equals to 35 times capital Q plus 9. 9 is also satisfying this condition. So this means that the answer to this problem is 9. I told you that if you just immediately draw this conclusion from here, your answer is correct, but with the illogic, yes? So this means that it doesn't deserve the full points. Up to here, of course, you have done some work. Okay, is anyone finding another way of solving the same problem? Yes?
It's just an idea, but you could take 2a equals whatever
Yeah?
and subtract that by one of the two original statements.
But it doesn't work. It might be you probably you get something, you get the other one. Yes. Yeah, more or less it's the same combination. I don't know, might be, I mean, that would be a little bit of a loop. Yes, here we subtracted, then we got something. And then if you take this one, I don't know, substitute this one, then A will be eliminated. Yes, A will be eliminated, and then you get a combination between Q and Q prime, something like this. Okay, so that I don't think it will work. And I just mean, instead of multiplying by 7 and 5, could you find other combinations? Because do you remember we solved a similar problem with different numbers? It was 8 and 7. And when we multiplied and subtract, because 8 and 7 differed by 1, what I got at the end, I just got my A here. I don't know if you go to the previous example. If you have forgotten, you can check the video. But in this problem, the problem is exactly the same structure, but I have changed the numbers from 8 and 7 to 7 and 5. In that case, when I do this subtraction, there is a 2 here. But I was thinking that might be we can also do it a little bit differently. Let me pause recording and we can think about it together. So, I mean that can you find another multiple of this one? So on the one hand, you need 35. Yes. On the other hand, you want to multiply by some number so that when you subtract, it becomes exactly A, or so that when you divide, you don't have a fraction so that you can skip this part. Yes? Let us just see if we can do that. Yes, yes, I'm repeating because I want to ask you about the, first of all, I did it a little bit in hurry. If you didn't understand, so that is, I'm just talking about it again. But the point is that can we solve it a different way? That was my intention. I was just thinking about, might be we can find a different solution to this. Let me just pause recording and see that we can find another way. But the point is which number? You do the hard part, you leave the simple part for me, yes? Yeah. Is it working or not? So let me just, instead of multiplying by 7 and 5, so let us multiply by 14 and 15. I think it will also work. Yes, let us double check. So if I multiply this by 14. So what happens? It becomes 14 14a is equal to, let us keep 14 times 5 times q, and then that becomes 56. So I multiply the first one by 14. So if you don't mind, let me multiply by minus 14. Yes? And I multiplied the second one by 15. So this becomes 15a is equal to 15 times 7 times q prime. And I multiply this by 15, it becomes 30. Agree? But if I subtract them, now it becomes a if I add them. But the point is that, do you think, because that is, I could actually find these numbers, but the point is that I need 35. But I have 35, yes or no? Yes, because here, this is 2 times 7 times 5, which gives me a 35. And this one is 3 times 5 times 7, which also gives me 35. Yeah. Okay, so that was the point. Yes, so not only I was able to find numbers so that when I add them it becomes exactly 1, but I also did it in a way that I don't lose my connection to 35 somehow. Okay, so that's what. Now if I add them, so this gives me my 35, 3 and q primes are left. This gives me my 35, 2 and q are left. So still I can factor a 35 out. Yes? So what is left from here? 3q prime is left. And from there, minus 2q is left. But of course, I have to pay something more, yeah? Because now I have something problematic here. But you have more experience. I mean, this is more straightforward than these kinds of arguments. Okay? So because we have experience, when I add them, it becomes minus what? 26. Of course, it is not acceptable, but you have enough experience. You don't need to be smart to understand this. But sometimes these kinds of reasonings are not that easy. Okay, but I mean, this is more straightforward. So what should I write? Of course, I can call it q here, but the point is minus 26 is not acceptable. So what should I do? This is something probably you should immediately be able to tell me what to do, what I'm supposed to do. Okay, thank you. So what should I do? Yes. Minus 35. That is easy, yes? Minus 35 plus. By the way, no, plus 9, sorry. Yes. And now you see that now I can factor another 35 out. And if you don't mind what is inside, there are no fractions involved in that case. So then I can safely call it capital Q. And then I have my 9 up there, yes? So that's also one way of doing it. So if you can find those numbers, then you really don't need to go through this process. And I remember there was one question left that I couldn't find time to solve that problem. So what was that problem? Is it this one that I have written? So let me see. Okay, so a is an integer. A is an integer. This belongs to z. And then we know that if I multiply this number by 7, and I divide this number 7a by 17, the remainder turns out to be 12. Yes? Now the question, so this is the remainder. Now the question is that if instead of dividing 7a by 17, I divide a by 17, what will be the remainder? I think what's the question? This question that I wrote. Okay. Yes? Okay, so let us do at least some part of it together, and then I will ask your opinion about how to continue. So the first thing, I am sure that if you have studied the lesson, it's immediate. So when you say that if I divide 7a by 17, the remainder is 12, the mathematical translation of that is there exists a unique. By the way, do you remember? Sometimes if you want, you can emphasize the uniqueness by putting that exclamation mark there. So there exists a unique Q in Z such that if I write 7a can be written as 17 times that Q plus the remainder is given to be 12. And then you have enough experience in the scratch work. What is your goal? Your goal is to write A as 17 times Q plus capital R, and then you have to respect that this number should be somewhere between these two. So the goal is clear. But what is your opinion about it? Because the first temptation is to divide everything by 7. And then you know why it doesn't work. Yes? For the two reasons here. First of all, this becomes Q over 7. And there is no guarantee that Q over 7 is an integer even though Q is. Another problem is that here I also get 12 over 7, which is not in an integer. So I have problems here by dividing, even though dividing seems to be the most natural one. Okay, so then what I'm supposed to do here? And of course, another natural step is to do what? To subtract 6a. That's also another natural one. But if you subtract 6a, this will work here, but then what? It becomes 17q plus 12s minus 6a. I need a multiple of 7. It doesn't work again. Yes? Sorry, I need a multiple of 17. I don't know. Do you have any idea what to do? You might say that, okay, I would write it as minus 17a and then plus how much? Plus 9 a's, but then again, of course, I can factor these two, and I have my 17, but again, 9n is left. So apparently it is not possible to fix it, or unless you have a smarter way to do it. Okay, so apparently these natural methods are not going to work. Then what? So division didn't work, subtraction or addition didn't work. So what is the next thinking about? Yeah, multiplication. Even though it is a little bit unrealistic, but you have enough experience, odd things that can happen in number theory. Yes, and multiplication actually works here. Yes, but multiplication by which number? So what is the goal? The goal is to multiply by a number so that there are some multiples of 17 appearing so that you can move to the other side, but 1 is left here. It's extremely simple. It's not hard. But I want you to know the strategy. So the strategy, if I multiply by 10, it becomes, for example, if I multiply by 2, it becomes 14a. It becomes 2 times 17, so far so good. And then I will have 24 here. But then, in order to keep a here, I have to move 13 a's to the right. But then I have problems because 13 is not multiple of 17, so that I can factor 17 out. So, so on the one hand, so that's the whole point. You need to multiply by a number so that when you take enough multiples of 17 out, 1 is left. 1 is left. What that number is? Don't look for big numbers. That is very simple and handy. Just give me the number that I have to multiply. Yes. The number is 5. So if you multiply by 5, what will happen? This becomes 35 A's. This becomes 5 times 17Q. By experience, you know, of course, I can multiply, but you know that at the end, I'm supposed to take 17 out. So why even I should bother to multiply this? You know, because you multiply, you're using a little bit of the bread that you have written for multiplication. So let us save it for future, okay? Energy crisis, yes. So then I will have, and then I will have 12 here. Oh, no, sorry. This you have to, you have to multiply. There is no way out of it. So this is 60. But now you see that actually Aryan could find the answer correctly because I want to make it A. So then I have to move 34 A's to the other side. And then fortunately 34 is also a multiple of 17. It's 2 times 70. That's correct. Thank you. So then it becomes 30. So let me just write A. And this becomes 5 times 17 times Q plus 60. And then I move 34 A's to the right. But now between this and that, I can factor my 17 out that I need. So this becomes 17. And then I have 5Q minus 2A. And then I have plus 60. Another problem that happens is 60 is not acceptable now. But this is something you already have enough experience how to solve it, yes? Because 60 is greater than 17 and cannot be the remainder by definition. But what should I do now? I hope that you can do this immediately, yes? What should I write instead of 60? Hmm? Yeah, no worries. But what is the method? You need to give me the highest multiple of 17 which does not exceed 60. Yes? 3 times 17 plus 9. 3 times 17. So this is nothing except 51 plus 9. Why on earth I chose this combination? Because this is the only one works. Okay, of course I can write 60 in infinitely different ways as the sum of two numbers, but I need this number to be smaller than the 17 on the one hand. On the other hand, this should be a multiple of 17. So now again, I would write A is equal to 17. I have 5Q, I have minus 2A, I factor this one, it becomes plus 3 and plus 9 finally. And can I call this one safely to be Q, capital Q? Yes, because Q and A are integers, so definitely this combination as an integer. And can I call this the remainder? Yes, because it satisfies this condition. Yes, so the answer to this problem is that if 7A divided by 17, the remainder is 12, the remainder of A itself by 17 is 9. Yes, is that clear? Okay, good.
Why is the 3 not in the, why is 9 not in the parentheses of 3? How did 3 get in the parentheses?
No, I am taking 17 out from these two.
Yes, when you factor it.
Yes, this 3 is coming. This is 3 times 17, so 3 is left. 9 is out.
Shouldn't it be like 5Q minus 2A in parentheses, then 27?
No, no. What I am doing is, so here I have 17. I have 5Q minus 2A, and then plus 51 plus 9. This 51 is 17 times 3. Between these two, I take 17 out. When I take this out, the whole thing is left. And from here, plus 3 is left, and then plus 9 is at the end. Yeah? Okay, so let me give you two more examples, then I will leave you on your own to practice. Okay, so I think this one you can do. So let me just write it down and wait for you. So A and B are integers. And we know that if I divide a by 17, so let I write it in a summarized form, okay? I divide a by 17, the remainder is 3. And I then divide a again. No, sorry. I divide b by 17 again. The remainder turns out to be 7 this time. Okay? But the question is that what happens if I divide 6a minus 9b by 51? What will be the remainder? Okay? A divided by 17, the remainder is 3. B divided by 17, the remainder is 7. Now I am asking you, if I divide this combination by 51, what will be the remainder? I want to give you a little bit of time so that you can think. Okay, anyone? Yes?
So can I say what I did?
Now, what the answer is?
I'm not there, but I'm in process.
So it means that you are not done, okay? Yes, you? This is a multiple choice question. I have 6 in one of my options, so but I haven't solved the problem. What is your answer? 6. Probably it is not a coincidence. Okay, so let us try to see if still some of you cannot solve the problem. So you need to read the text. A is a number, so that when you divide it by 17, it becomes 3. So the remainder becomes 3. So if you want to translate the first sentence, it means that there exists a q in Z, so that A divided by 17 multiplied by that q plus 3. Yes, everyone should be able to write this down, so that's not hard. And then the second sentence, b divided by 17, the remainder is 7. So this means that there exists probably another integer q prime z in Z, so that b divided by 17 gives me b is equal to 17 times q prime, and the remainder is mentioned to be 7. And I think it is not hard. Might be the numbers are a little bit big, but you can use your calculator, of course, in case. So 6a minus 9b is the combination that I need. I go to a scratch paper. What I am supposed to do to answer this question mark, I should be able to write 6a minus 9b as 51 times q plus r, and then I have to respect that r should be somewhere between 1 and 51. So this is my goal, so that it is clear in a scratch paper, okay? So this immediately motivates me what to do. Yes, it is extremely simple, yeah? What I need to do, I make that combination. 6 times A minus 9 times B. So that is very natural. So what it motivates me to do is to multiply this 6 by 6 every time, everywhere. So this becomes 6 times 17 times q. I can of course multiply, but let us keep it. So this becomes 18. And I multiply this by minus 9. It becomes minus 9b equals to minus 9 times 17 times q prime. And then minus 9 times that is minus 63. Yes? And then because I want to have the combination of 6a minus 9b, so I add them side by side. So this becomes 6a minus 9b. Okay, so for example, for the time being, let me just factor a 17 out. Then it becomes 6q minus 9q prime. And then 18 minus that one is minus 45. Yes? So this is something that we have to address how to solve, because in the scratch paper I realize I do not need a factor of 17, I need a factor of 51. Do I need to do something? Yes, but it is extremely simple, because between 6 and 9 I can pull out another factor of 3. So this means that 6a minus 9b, if I pull a 3 out, then that 3 will make this one to be 51, exactly what I need. And then this becomes 2q minus 3q prime. And then hopefully you realize you have a little bit of problem with negative numbers. Negative numbers are not acceptable as remainders. But the fix of this is you learn what to do. What I'm supposed to write, it should be somehow related to 51. Yes?
It's a sum of minus 51 plus 6.
Plus 6, exactly. And then you realize what is happening between this and the whole combination. I can pull a 51 out. So this is 2q minus 3q prime and minus 1 and then finally plus 6. Now I can safely call this capital Q. What matters is that this is indeed an integer. And 6 satisfies that condition. So the answer to this problem will be 6. Yes? Okay, let me just one more problem and then we are done. You can start working on your own. So let me write this question in a very short form. So you have a and b integers, non-zero. If you want to, let us say a and b are non-zero. If you divide 2a by b, the remainder is 16. If you divide 3a by the same b, the remainder turns out to be 3. The question is not finding any remainders, the question is to find b. Yes? So I've been lazy a little bit, but I'm just talking about this orally. Take this number, divide by b. The problem tells you that you get 16 as the remainder. If you take 3a but divide it by the same b, you get 3 as the remainder. This time the question is asking what is this missing number b. Okay? So this problem is a little bit hard. So let me make it for natural numbers. If I say integers, you have to consider a lot of cases with positive and negative, and that is nothing interesting. So let us make everything in the set of natural numbers, okay? Of course, this doesn't mean that we cannot solve it for z, but we have to consider different scenarios. So let me consider that a and b are positive whole numbers, rather than considering two scenarios, because this is not one of those problems that you just solve and find b exactly. You have to consider some cases.